Hello everyone, welcome to Vijay Codes. So in today's video we are going to cover one of the most important interview question, that is repartition versus coalesce. So this won't be asked directly in an interview. First the interviewer would be like knowing your knowledge about repartition and coalesce, and then only it would be asked. So to understand why we need repartition and coalesce, let's understand what was the problem before. Let's say we have five partitions of data, 2 MB, 25 MB, 20 MB, 15 MB, and 10 MB. So, for example, we have these five partitions of data. What will happen is, let's assume this data is on executor 1, this is on executor 2, this is on executor 3, this is on executor 4, and this is on executor 5. When the data is processed on the executors, the executor 5 would be empty because it is processing less amount of data, and then the executor 1 would become idle as it is processing 10 MB of data. So in this case, E4 would be taking a lot of time to process the data, and hence rest of the four, E1, E2, E3, and E5 would be waiting on E4 to like process the data, and hence after they can return the result to the driver. Let's understand when this problem occurs. So what happens is when you are doing group by, in our previous video, we have seen that group by creates by default 200 partitions. Let's say one of the partition is too big when compared to other partitions. And after group by, if we are doing any kind of steps, the bigger partition would take a lot of time because there is a lot of data present in the bigger partition. Due to this reason, our whole process would be slowing down. For to resolve this issue, we have two options, either to repartition or coalesce. So let's understand the difference between them. So what repartition does is it would be repartitioning the data across all the partitions, and it will make sure that each partition has equal amount of data. But what Coalesce does is Coalesce will be adding up the partition. So in our example, we had one partition of 2 MB, one partition of 10 MB, one of 15, and one of 20, and one of 25. So what Coalesce would do is Coalesce would be adding the partition of 10 MB and 2 MB together. So we would end up with something like this, four partitions, one of 12 MB, one of 15 MB, one of 20 MB, and one of 25 MB. So what Coalesce basically does is it would add two different partitions to reduce the number of partitions. Whereas repartition does is it distributes the data equally among the number of partitions. And due to this reason, we are able to solve the problem of hotspot. Now, no partition is basically like the hotspot. With that being said, if we are solving the problem of hotspot in repartition totally, why do we need the coalesce? Because in coalesce, in some sense, we are still having the issue of the hotspot because one of the partition size is greater than the other partition size, as 25 MB is greater than 12 MB. So why do we still need coalesce? That's where the advantages and disadvantages of repartition and coalesce comes into the picture. So repartition is, it is a Wide transformation. We have taught narrow and wide transformation in our previous video. So I would highly recommend that to understand what a wide transformation is, you should watch that video first. And Coalesce is a narrow transformation. So since repartition is a wide transformation, there is shuffling involved. Let's say these are the five partitions. So there would be shuffling involved across the clusters or across the partitions to reduce the data within the partition and equally distribute the data in the partition. Since Coalesce is a narrow transformation, it would avoid the data transmission between the partitions. Due to this reason, repartition is compute heavy, and whatever involves compute is costly in nature. Whereas Coalesce is not that costly as it doesn't involve shuffling of data. Another disadvantage of repartition is it is slower than Coalesce. As there is shuffling of data involved in repartition, the performance while doing repartition is very slow. However, when doing Coalesce, it is faster than the repartition. So these are few advantages and disadvantages of repartition and Coalesce. So the question would be, when should we use it? Remember one thing, whenever an interviewer asks, when will you use repartition or when will you use Coalesce? So the answer to this question would be always it depends. It depends on the data, it depends on the use case, it depends what the issue is, what we are trying to solve. On the basis of that, we will be choosing we should do repartition or we should do Coalesce. Also, one other point is that in repartition, we can either increase or decrease the number of partitions. Let's say we have five partitions and the data across the five partition is queued. So what we can do is we can do repartition and we can instruct Spark that now we want six partitions. So what Spark will be doing is it would be creating six partitions and distributing the data across those six partitions equally. But in Coalesces, we can only decrease the number of partition. Let's say we have four partition, and even if we do Coalesce of five, we will be getting only four partitions because Coalesce cannot be used to increase the number of partitions. Because in Coalesce, what we were doing is we were adding two partitions to create a different partition. So since we are adding two different partitions and merging them, we cannot increase the number of partition. It would be always decreasing or remaining the same. And hence in Coalesce, we cannot achieve more partitions than the previous step. So when the use case is that you require more partition than the previous step, you have to go for repartitioning. You have no other choice because in Coalesce you cannot increase the number of partitions. That's it for today's video, guys. Hope you were able to understand what repartition and Coalesce is, why do we need them, when to use them. Make sure to watch this video again as it is one of the most important interview questions. Thank you so much.